You remember when we left off, I was setting you up for the fact that we needed to move this VLAN traffic from device to device. And what we're going to use to do that is our trunk links. By the way, the name trunk comes from the public switch telephone network type technology, where we take multiple phone conversations and we send those over the same media. So that trunking concept we borrow from the voice world. Notice here in this illustration, we've got all of these multiple VLAN participants, and all of that traffic can be trunked to this central switch. And this will allow for communications between these different VLANs. So trunk links are a critical component that's going to allow that traffic of one VLAN to be carried from Cisco device to Cisco device. The way in which the world is settling on how to trunk in Ethernet now is with the standards-based technology called 802.1q. That's right, 802.1q. This is really the standard way to do it now. And it wasn't always that way. You see, Cisco originally invented their own trunking protocol called ISL, Inter-Switch Link. In this approach, the original Ethernet frame would be encapsulated. It would get a new header and a new footer, and inside the new header would be the VLAN identification information. Well, in 802.1q's approach, they don't re-encapsulate the frame. Instead, they insert that tag field, that third field that you see there, the tag, and then they compute a new frame check sequence at the end of the frame since they did manipulate the frame. So the 802.1q approach inserts a tag value because let's face it, when it comes to identifying the traffic as belonging to a particular VLAN, we need some kind of VLAN tag associated with the traffic. If you expand and look at that tag in greater detail, you'll see that sure enough, there is, as I promised, an area that holds the VLAN identification. So notice there's our VLAN identification field. And notice the PRI. What's that field all about? Priority. That's right. This is used in quality of service to show that the layer 2 frame might be something very important like voice traffic. Now, 802.1q trunk links have a very important concept associated with them that for some reason tends to drive students crazy. But it's not going to drive you crazy because I'm going to clearly explain what this is all about. It's called the native VLAN. You see, in an 802.1q trunk world, every single trunk link receives a VLAN tag for all the VLANs except one VLAN. That's right. In your environment, there's going to be one and only one VLAN that does not get a tag ID for identification of the traffic for that native VLAN. Let me repeat it. All of your VLANs are going to get that tag for VLAN ID except one special VLAN. This one special VLAN will not have its frames tagged, and this is called the native VLAN. The idea behind this was, let's take VLAN 1, for instance, and let's not tag it so that if we ever had a failure of the trunking or any kind of failure, that traffic would still flow. It won't possess that VLAN modification. The idea here was you would put your management traffic in that VLAN, that important traffic that you need to be able to flow to your devices. Now, let me let you in on a little secret here, folks. The native VLAN, it actually can end up being exploited by computer criminals. So Cisco is shying away from you using this particular technique. Cisco's saying, you know what? Eliminate the use of a native VLAN in your environment by setting the native VLAN to something like VLAN 1, which it's set to by default anyways, and then not putting any traffic in VLAN 1. That's what goes on in production networks that are concerned about security. From an ICND2 perspective, you just have to understand what the native VLAN is. It's a VLAN that's not tagged with an identifier for the network. So don't stress out about the production aspects too much, but for passing the exam, just know what that native VLAN is. But again, I'm not here just to teach you the exam. I'm here to teach you what goes on in production networks, and because there are security concerns with native VLAN, it's often not used today. We set it to a VLAN, and then we don't put any traffic in that particular VLAN, effectively not using the native VLAN concept. Now, we'll go ahead and create some VLANs and create some trunk links coming up, but there's some more technologies that we want to talk to you about before we get on our switch and actually start creating this stuff. Let's think about this for a minute, folks. If I go over to this device right here and I create some VLANs, I would love it if those VLANs would automatically go and get created on all the other devices. That would be great. Otherwise, I'm going to have to create my VLANs here and then come over here and create them, and then come over here and create them, and then create them up there. That's a little work. In production, that's often how it's done, believe it or not. What the administrator will do is they will create the VLANs here, copy that out to Notepad, that config, and then create them there, pasting them in from Notepad. But if you want a protocol to help you out with this, there is one from Cisco available. It's called the VTP protocol, the VLAN trunking protocol, and it's got a terrible name, doesn't it? The VLAN trunking protocol, it would be better called VLAN management protocol, because what it's really doing is it's allowing you to manage your VLANs. There is one thing I like about the name VLAN trunking protocol. It reminds us that it will only work over trunk links. Yeah, this technology is only going to function over bona fide 802.1q, for example, trunk links. This technology is not going to function over non-trunk links. So that's one good thing about the name VLAN trunking protocol, but a much better name would be the VLAN management protocol. Well, let's hear a little bit more about this magic protocol that allows us to share our VLAN information. And to help us out with this, it's our good friend and double CCIE. His name is Ed Yanez, and he's one of our guest experts here at Stormwind Live. We're going to go ahead and bring in Ed to talk to us a bit more about this VLAN trunking protocol.
You want redundancy for critical parts of your network, whether it be in the core, distribution, or access layer.
I'm sorry, I had to cut Ed off there. Ed was speaking about something that we're not ready to talk about yet, and that's redundancy in our switched infrastructures. It's actually our guest expert, Mike Vasquez, that is going to come in, yeah, now I've got it right, and speak to us about the VLAN trunking protocol. So let me go ahead and dial in.
I think all of us have one thing in common. We'd rather make our jobs easier than harder, right? That's where VLAN trunking protocol, or VTP, comes into play. It's a Cisco proprietary solution designed to lessen administrative overhead of VLANs across the network. If your background is with another vendor, you may be familiar with other similar solutions such as GVRP or MVRP. VTP operates at layer 2, and its role is to ensure VLAN configuration consistency. So VLAN additions, covered. Deletions, name changes, covered. And by managing this, common problems like misconfigurations and inconsistencies, which can create huge headaches, are avoided. Things like duplicate VLAN names or incorrect VLAN type specifications. These problems become a thing of the past. Now, let's consider the catalyst switch. By default, is initially in a no management domain, kind of like a blank slate. It remains in this state until one of two events occurs. If it receives an advertisement for a domain over a trunk link, or you go in and actually configure a management domain. On your VTP server, when there are configuration changes, these are then sent across all the trunk links to all the switches in your network, and the modifications are propagated, maintaining that consistency we strive for and avoiding the configuration errors we mentioned previously. And that's what's great. All of this is done automatically. Your domains are synced, VLAN configs are consistent. Is there a gotcha? Well, you bet, and this is a big one. Since it's automatic, well, be careful, because you want to ensure that switches you add are in their default VTP configuration. Why? Well, if they aren't, guess what? That switch's settings may conflict and supersede your existing VTP configurations. Yeah, that's a nightmare and a huge effort to fix. So before adding a switch, you must ensure it's in the default VTP configuration.
Well, thanks so much, Mike Vasquez, one of our guest experts here. We'll be hearing from Ed a little bit later on. He's going to help us out with the spanning tree protocol. But that was Mike Vasquez helping us out with that VLAN trunking protocol. If you decide to use it in your network infrastructures, it really can make life pretty simple. You're going to configure a VTP server, like that device up in the top of this illustration. And what's going to happen is you'll go and add or delete a VLAN to that VTP server. And then notice it's got a bunch of devices below that are set up as VTP clients. Sure enough, it'll propagate the change out to those VTP clients, and they will get that new VLAN. Then they'll synchronize to that latest change. So you can manage your VLAN database from just one device and take advantage of this particular protocol's management across the different devices. Now, one of the things that you might notice in this particular simplified example is that there's only one VTP server. What happens if that one switch were to fail? Well, now you've got clients that don't have the ability to create or manage VLANs. They are acting as slave-like devices to the VTP server, and they'll be in a bit of trouble. They'll just be stuck with their database. That's why in a true production environment that does VTP, you would have at least two VTP servers to go ahead and back each other up. Let's go ahead and take a look at the three different potential VTP modes that we have. By default, all of your Catalyst switches are going to be in what's called server mode. They're going to be in a mode where you can create and edit and delete VLANs all that you like. So by default, they're all in the mode of VTP server. You can go ahead and go to certain devices and you can give them the role of client. When you put a device in the client mode, it can no longer create or modify or delete its own VLANs, and it's going to be in that slave-like operation to your server or servers that are out there on the network. All of this is pretty easy, of course, to memorize, right? Makes sense. We got a server, we got a client. Now here's where the trouble comes in for students. The trouble comes in on a third mode that Cisco created called transparent. Here's the deal with a transparent device. It's like a server in that you can go ahead and create and modify and delete VLANs on it. But guess what? All that information is going to stay local. It will ignore updates from the server. It will pass them through to clients, but it won't do anything with the updates. The transparent device is very stubborn. It'll just look at its own VLAN database and not sync to a server's. Pretty interesting. Again, a key element of the transparent device is that it will send updates through to the clients. It won't listen to the updates, but it will pass them along. That's why it got its name of transparent, by the way. So, VTP transparent mode. Don't be confused by it. It's just a mode where you can do anything you want there locally with your VLANs, and you will not impact anyone else in the topology. It's a mode where you might have a lab device and you want it plugged into your network, this laboratory equipment, but you want it operating with its own localized independent copy of the VLAN database. So 3 modes, know them and know them well. By the way, VTP operates with a simple configuration revision number type of approach. So what you have here is like the server will have a new VLAN added to it. So the configuration revision number will bump from, let's say, 3 to 4. And then sure enough, the server updates the clients with this information, and the clients go, hey, wait a minute. I am at revision 3, and I'm seeing information that's revision 4. 4 is bigger than 3, so I better go ahead and update based on this information. I mean, that is the simplicity with how this protocol operates. And I'm not kidding. It's that simple, folks. A number called this configuration revision number is what dictates whether we synchronize. You can quickly see where this is going to get us into a big potential problem. What if you have a Cisco switch with a high configuration revision number? Let's say it's like 50, and it has an empty VLAN database, and you plug this in as a server to that domain. Yeah, all the clients will go, whoa, configuration revision number of 50, this is new information, and the clients will erase their databases. Mike Vasquez in our guest expert video a few moments ago actually talked to us about this potential occurrence. So we want to be very, very careful with this. When we introduce a new Cisco switch into our VTP domain, we want to be very, very careful that that new switch we're introducing doesn't overwrite information thanks to the simple configuration revision number. I'll show you how to be careful about this in production environments at our equipment once we get to that point. In fact, we're almost there where we're going to get to configure all this stuff. I know you're anxious to see it. But one last topic I want to talk to you about before we do that. And it's a topic that is really pretty cool. If you decide to use VTP in your infrastructure, you can take advantage of something called VTP pruning. Yeah, VTP pruning is really pretty neat. What VTP pruning will do will dynamically eliminate traffic from going down trunk links where it doesn't need to go down. Yeah, let's take a look at this. Notice how VLAN 3 is only here and over there. Notice where the 2 PCs, let me get out of the way so you can see this. Notice there's 2 PCs in VLAN 3 here. So VLAN 3 broadcasts, for example, don't need to go down all of the trunk links. VTP pruning, like we're pruning the leaves off of a flower. VTP pruning will dynamically stop the VLAN traffic from going down those other trunk links unnecessarily. Isn't that cool? So it's a protocol built into VTP that really adds to the efficiency of our network communications. We don't need to send broadcasts down those other trunk links, and dynamically, they will be pruned off. Configuring VTP pruning couldn't be easier. All you do is you go to your server and you turn on VTP pruning, and that setting propagates to all of the clients and other servers in your VTP domain. The tough thing about VTP pruning is understanding what it is. That's actually pretty easy. And once you get that, again, configuring it is a piece of cake. We go to the server device, we turn on VTP pruning with the VTP pruning command, and then we are ready to go. Speaking of configuring our layer 2 environment, here's the to-do list. I love it. It looks like one of our personal data assistants here, our graphics team made for us. Our to-do list for configuring things. You could go in and you could give the devices their VTP config, and then you better go in and do your trunks, because without your trunks, you're not going to have VTP working. VTP only works over trunks. Once you got your VTP and your trunking in place, you can go ahead and create your VLANs. You can then go ahead and assign the appropriate switch ports to the appropriate VLANs, and then you could always do any changes that you might need to make. And then finally, yeah, of course, you better save everything. And you better back up these configurations in case there's a problem on your devices. We never want to just go with the configurations on the devices. We want to make sure we're backing up these important configurations in our network infrastructures. So that's the list of events there. And what's interesting about this is you could actually do them in a different order. A lot of administrators like to create their VLANs first on one server, and then they create their trunks, and then they do their VTP. That's another valid order. I guess you could always do your trunks first, then do your VTP, then do your VLANs. So you don't have to do it in this rigid order, but obviously you do want to build a particular, well thought through system that you're going to do all this configuration work with. Let's do it in the order that ICND2 does it. So we'll start with VTP, then we'll do our trunks, then we'll do our VLANs, then we'll do our VLAN membership. So we will stick to the ICND2 process here. Notice the defaults for your VTP. You're in a domain of nothingness. You're in a VTP domain of null. That means VTP isn't working on your equipment. Okay, so by default, VTP isn't working. Your default mode, like we talked about, is server mode. Your VT pruning's obviously disabled. Those are the things we really care about. So VTP, long story short, it's not running by default. Okay, folks? We're going to go in and configure it if we want to configure it in our network infrastructure. So let's jump over to our equipment and let's do just that. So we're going to jump over here to switch 1. Now, one of the things you got to watch out for with switches is they may be trunking on their own. That's right, the switches might be trunking on their own thanks to what we call dynamic trunking protocol. We haven't talked about that yet today, but there is this DTP, not VTP, DTP, D is in Delta. The dynamic trunk protocol has this particular device automatically trunk with another Cisco device. Let's check this. Show interface trunk. The show interface trunk command we use a ton, and that is to verify whether or not we have trunk links. And look at this. We have a whole bunch of trunk links that dynamically occurred between the equipment. Notice they're using the old school interswitch link from Cisco. Yuck. So not only did we get all these trunks form without our knowledge of that, but we had the trunks form and use a very old, proprietary trunking protocol that we're most likely not even going to want to use anymore. Amazing. So one of the things I'll do right now is, notice the mode was desirable. I'll go to all of these ports and we can go ahead and, well, one easy way to take care of this is to shut them down. You ready for this? I'll go to interface gigabit 0/1 and I'll shut it down. That'll take care of that trunk. And then I'll go to interface FA0/1. We'll do this. Interface range FA0/1 to 24, and we'll shut those ports down. All right, now we are clearly not going to have any automatic trunks formed. Let me check that with show interface trunk. No trunks. Okay, no trunks. All right, so now we're truly going in the ICND2 order. There are no trunk links on this device, and we're going to start with VTP. Okay, so on switch 1 here, we'll make switch 1 our VTP server. But wait a minute. We said all switches are a server by default. Yeah, that's right. So actually, I don't have anything to do in that regard. Let's check that it's a server. How we check that it's a server is the command show VTP status. Memorize this command, folks. Show VTP status shows us the VTP configuration on the device. It says, Anthony, you're currently running VTP version 1, although you are capable of the new and improved VTP version 2. Great. Your configuration revision number is at 0 because you haven't made any changes to the VLAN database. You have 1005 VLANs possible. You currently have the default 5 VLANs on the device. VLAN number 1, and then 1001, 1002. There's some default VLANs that'll always be there. Look, we're in server mode. So sure enough, all Catalyst Cisco switches are servers by default. We don't have a domain name because VTP isn't really running right now. We're in that null domain that I spoke of. VTP pruning is turned off. VTP version 2 mode, we're not in version 2, and then some other info you don't have to worry about. So, wow, we are a server already. So all we need to do is go in and join a particular VTP domain. We go into global configuration mode and we say VTP domain, and then we give the case-sensitive domain name for this particular device. Yep, case-sensitive domain name. So we're going to go in and we're going to say CCNA _ domain. Notice how I use all uppercase here. I use all uppercase because the name is case sensitive and I don't want any problems with that. So I don't want to have to remember what case I used. So when I'm naming things at the command line, I always use all uppercase. So now we're in a CCNA domain here on switch 1. And that's how easy it is. We've got our server configured on switch 1 for the CCNA domain. I'll end and I'll copy, run, star to save. So we've saved that config. Let's go over to switch 2. All right, switch 2. We're going to go ahead and name it hostname SW2. And I'll go into the console port and I'll say logging sync exec time 00. And we always want those commands. And now I'll go ahead and, let's see, show interface trunk. No dynamic trunk links created. Great news. And now we'll do show VTP status. And sure enough, it's a server in the null domain. What we'll do on switch 2, you guessed it, we'll go ahead and make switch 2 a client mode VTP system. So we're going to go and we're going to say VTP domain, is CCNA underscore domain. Got to match it exactly to what we said on the other device. And then we'll say VTP mode, first time we've seen this command, VTP mode client. And now we're in the client mode. We'll end and save. So on this device, we do VTP mode client and we do VTP domain and our domain name. So now we've got a server and we've got a VTP client. What's interesting about this is there's no trunking in between. So VTP is not working between this server and this client because there is no trunk link. But obviously one of the things that we're going to be doing here coming up is to create a trunk between these two devices. Once again, I want you to have memorized how we verify the VTP configuration. It is show VTP status. We can see now we are indeed in client mode. We are indeed in the CCNA underscore domain. So show VTP status, absolutely critical. Absolutely critical, that particular command. Well, we are now ready to begin our trunking between these two devices. VTP isn't going to totally work. In fact, VTP isn't going to work at all until we get our trunking done. Until we have valid trunk links between these particular devices. So, with trunking, we got to make sure that the same native VLAN assignment is used between the two devices. Now, the great news on the native VLAN setting is that it is going to be the same by default. By default, Cisco uses VLAN 1 as the native VLAN across all of the devices. So by default, the native VLAN is going to match. Just keep in mind that if you change that for any reason, if you change the native VLAN on one end of the trunk, you better change it on the other end of the trunk. You can't do any of that fun port security that we saw in ICND1. And you're going to use dynamic trunk protocol in order to manage the negotiation of the trunk link between your switches. All right, let's go in and see how we would trunk between our switch 1 and our switch 2. Now, what I need to do, though, before we can do that, is I need to just see real quick the topology, and I'll show you here in a second. In fact, I can show you right now. Let's take a look at the topology that is utilized by our Proctor Labs folks for the switches. We have Cat 1 and we have Cat 2, and we can see that they're connected utilizing Fast Ethernet 0/19, for example. We can see it right here. So those two switches that we've been playing with are connected using Fast Ethernet 19. So now we know the port that is connecting those two. You might say, Anthony, why did you have to check on the Proctor Labs setup? Couldn't you just use show CDP neighbors? Well, I have to use the topology diagram in this case because remember what we did? We shut down all of the ports on Cat 1. Yeah, we shut down all of those ports. So show CDP neighbors in that case isn't going to help us. Okay, so we've determined that FA0/19 is indeed a link between switch 1 and switch 2 on our equipment. Great news. So now we can go over to the equipment, and let's go back over to switch 1. And on switch 1, we'll say interface FA0/19, and we'll say switch port trunk encapsulation .1Q. The first thing that I do here is I tell this particular interface, hey, look, I want you to trunk, and I do not want you to trunk using that old ISL encapsulation. I want you to trunk with 802.1Q. So we say switch port trunk encapsulation .1Q. Okay? Now I have to tell it to be a trunk. Switch port trunk, switch port mode trunk. So now we've said, okay, this is the trunking protocol you're going to use. Now I want you to actually trunk. And then what we do is we could say switch port trunk native VLAN. And this is how we could manipulate that untagged VLAN. But guess what? I'm not going to do that. I'm going to erase that. I don't want there to be any manipulation of the native VLAN. I'm fine with the default native VLAN of VLAN 1. All right, I'm gonna leave it right here. So we did switch port trunk encapsulation .1Q. We did switch port mode trunk. Now what we have to do is go to the other side, switch 2, and do the same settings, and then we'll bring up the trunk. So I'm going to go in to interface fast Ethernet 0/19, and I'm going to say switch port trunk encapsulation .1Q, and I'm going to say switch port mode trunk, and I'm going to go ahead after setting that up. I'm going to end and save with copy run star. And now we've got both ends of the link set up the same. So I'm going to go over to switch 1. And we got the settings in there. All I'm going to do is no shut it. We had shut it down. Now I'll no shut it. And we should see it go down and then up. Good news. And now we verify our trunk was created correctly. How do we verify? Show interface trunk. And it says, all right, great job, Anthony. For fast Ethernet 0/19, the trunk mode is on because we used the switch port mode trunk command. The encapsulation, because you told me to do it, is 802.1Q. The status is trunking, and the native VLAN assignment is 1. Under the VLANs allowed on the trunk, all of them are going to be allowed across this trunk, but right now only VLAN 1 is actually operating. So we can see, and really all you need at the CCNA level is this first row. We can see that we have indeed created successfully our trunk link. But you know, we really haven't seen anything come to life yet. And that's what we're going to do next. if I do show VTP status, I remember that this particular device is the VTP server, and switch 2 is the VTP client. So let's review now. If this is the server and we've got this healthy trunk between it and the client, supposedly, if I create a VLAN here, it will magically propagate to switch 2. Let's try it. Configure terminal, and let's create a new VLAN. Here's how you create a VLAN, folks. It's so easy. You go VLAN 10, for instance, and now you enter VLAN configuration mode, and then I can just go ahead and give this thing a name, like an optional name, like name test. So now we have just created a VLAN 10 named test. I'll create a VLAN 20 and name it test 2. And finally a VLAN 30 and I'll name it test 3. We'll end. We'll save our configuration. And that's how easy it is to create our VLANs. In global configuration, we say VLAN and give the VLAN number, and then we can apply an optional name. So we just created VLANs on the VTP server. We have a trunk link going between the VTP server and the VTP client. So drum roll please, everyone. When I go over to the VTP client switch 2, we should see these VLANs created there. Let's do it. We go over to switch 2, and we use a new verification command I haven't shown you yet. We're going to do show VLAN brief. The show VLAN brief command is how we can verify our VLANs. Remember, we're over on switch 2 here. We didn't create any VLANs there. We're hoping they propagated magically thanks to the VLAN trunking protocol, or VTP. Here we go, folks. And it didn't work. Look at that. There are VLANs 1 and 1002 through 1005, but there's no VLANs 10, 20, and 30 that we created. I'm excited about this because now we get to do some troubleshooting together, don't we? So interesting. Let's make sure everything's okay with the trunk link. Show interface trunk. And it says, yeah, we have a happy, healthy trunk link between these two devices. Let me make sure it's with switch 1. We'll do a show CDP neighbors. Oh, and look, we just got an error message. Okay, so first of all, we have a connection via Fast Ethernet 0/19. Look at that, with a device named switch. So I think we may have enabled the wrong device. Let's just check that Proctor Labs topology one more time. Cat1. Oh, Fast Ethernet 19 doesn't go to switch 2. Oh man, we got to do this on Fast Ethernet 23. I was looking at this labeling and I got it wrong. All right, no problem. No problem at all. Here we go. This is great because it'll give us a chance to do all this over again to review it, okay? All right, so we've got our VLANs created on switch 1. Now where we need to trunk is interface 23. Let me verify that. Yep, interface 23 is where we need to trunk. Okay, no problem. Watch this. We go over to switch 1 and we say interface Fast Ethernet 0/23. Switch port trunk encapsulation .1Q. Switch port mode trunk. Okay? And that's it. Set the encapsulation, set the correct trunk mode. Now we'll go over to switch 2 and do the same exact commands there. Under the 23 interface, we'll say switch port trunk encapsulation.1q. I'm going fast because this is review. Switch port mode trunk. We'll end. We'll save the configuration. And now we'll go over to switch 1 and we'll no shut the interface. And now we'll make sure the trunk link comes up, and this will truly be a trunk between switch 1 and switch 2. Show interface trunk. Now we see we got 2 trunks, the one over the 19 port that was going to like switch 4, and now we've got the trunk going to switch 2. Cool. Let's do a show CDP neighbors to prove it's going to switch 2. Yep, look at that output. Fast Ethernet 0/23 is going over to switch 2. Gotta love it. So we go over to switch 2 now, and we try show VLAN brief, and holy VLANs, Batman, look what's happened. Sure enough, now that we do have a true trunk link between switch 1 and switch 2, the VTP started working its magic, and we have VLANs 10, 20, and 30 created over here thanks to VTP. This is on switch 2. So this is very, very cool stuff. Now, we've got these VLANs over here, but the VLANs aren't doing anything. We can tell this by looking at this show VLAN brief output. You can see that these VLANs of 10, 20, and 30, they're not in any interfaces. So sure, they're on switch 2, but they're not doing anything. How do we take one of these VLANs and put it on an interface? Remember, we said we can do it statically instead of using a VLAN management policy server? So let's see how we do it statically. And obviously, you're responsible for this as a CCNA. Well, let me do a show interface status. This is another one of my favorite commands. And notice we've got a bunch of ports we can play with. Ports 4, 5, and 6, for instance, we can play with. They're not actually connected to anything, so we can't mess anything up. So let me go into interface 4. And in interface 4, I'll say switch port mode access. We take this interface and we make sure it's not a trunk port. That would be switch port mode trunk. And instead, we make sure it's an access port. Easy to remember that this port is going to be for getting people access to your network. And then we say switch port access VLAN 10, for example. And now we have just placed that switch port into VLAN 10. Let's go to interface fast Ethernet 0/5. And we'll say switch port mode access, switch port access VLAN 20. And then finally, interface fast Ethernet 0/6, switch port mode access, switch port access VLAN 30. And that's how easy it is, folks, to go into access ports, make them access ports with switch port mode access, and then assign them to their VLAN using switch port access VLAN. Those commands I've used so much in my Cisco career that I know them as well as I know my middle name. The verification, show VLAN brief. And when we issue the show VLAN brief command, we can now see that the VLANs of 10, 20, and 30 are participating in 4, 5, and 6 ports, respectively. So we love the show VLAN brief. It not only allows us to verify our VLANs exist on the device, but we can verify our VLAN assignments as well.